Friday, all of us will be there. Just convene in a large venue. So all of you guys will be there. And then Wednesday and Thursday, I'll be separately on Wednesday, and you'll be separately on Thursday. So it's nice to meet you guys. I hope you have one.
Thanks, sir. Thanks. And we love all
Yes, just a mini introduction. Good afternoon, everyone. My name is Franz Rafegile. I'm doing my diploma in accountancy finally, and I'm going to be your teaching assistant for this year, together with Jabulo for BNS module. Okay, so yes, we tried discussing the group thing. So on Wednesday, there's going to be a tutorial session for a certain number of you guys. Then also on Thursday or on Friday is going to be in a larger room, something like that, you see. So yeah, I can't wait to work with you guys. So see you guys next week, Thursday. Then we're going to see you guys on Wednesday. So nice to meet you guys.
Thank you very much. All right. Okay, so they will be helping you with the rest session, but also I'm there. Anytime you need my help, you can just come to me. I'm in the building 7, the math department. So if you need a particular help, one-to-one, you will just email me and then we meet. Or after the class, you can see me one-to-one after. Okay, so while the class is ongoing, you can stop me anytime. Okay? You stop me anytime. If you don't understand anything, just stop me. So I will not be using Beamer, I will use directly the whiteboard. Okay, so but you have already all the lecture material available, the assessment, everything is available online, so please just go through it. Okay? Okay? So Mrs. Jones started already, and I think I did also two classes. For some of you, I think I see the face now, some of you were there. So we start with numbers, okay? And because of the protest, we switched to online, and then we have 2 classes online. So I will just carry on from there. And all the 2 classes were recorded. So please go back to the recording if you're not following, because because we are following a timetable. I may not be able to go back, okay, to all that we discussed. I cannot go back, okay, because we are following a timetable, and then we are following the assessments also in order to keep in conformity with other. Okay, so we started to understand what is a number, the classification number, and we saw different type of numbers. Okay, so different type of numbers. But the most importantly, we understand that all numbers. If I say number and I don't specify it, any type of number, we should know that it is a real numbers. Okay, it is a real number. Okay, and then we learn that those real numbers actually they are of big group, and they cover other numbers called rational numbers. They cover other numbers called decimal numbers, natural numbers, integers, irrational. You see all those, yeah. And then we learn that we can actually do some ordering in these real numbers. If you take 2 numbers, you can always order them in real. Okay? Yeah. Depending on which criteria you want to order them. Okay? So every 2 numbers in real numbers can always be compared. We saw that, and then we also saw that if you take two real numbers, there is always some operation that we call plus and division. Okay. Let's multiplication, subtraction, and division. So those are the 4 types of operation that we are using actually. Okay. And we saw that we can do what we call associativity, associativity, distributivity, commutativity under the operation plus. and multiplication. Because if you take R under addition and multiplication, it forms what we call a field. Okay, that's a big deal. Like, yeah. So we have that the addition, and the addition is a group. What does it mean? It follows some property. Okay? If you take two numbers, two real numbers, and then you add them, you can always permute, right? If I say 1 plus 2 is equal to 2 plus 1, you have the commutativity. Okay? And you have the associativity. If I say 1 plus 2 plus 3, this is also equal to 1 plus 2 plus 3. That's the associativity. Okay? And also we have the distributivity. When you say distributivity, you talk about this, the distributivity of one operation over the other. Whenever you see the terminology distributivity, then it's two operations, one over the other. So if I say X, I'm taking S, and then I want to, let me take A. I want to distribute it over B and plus C. Okay? So I want to distribute, no, if you are coming, please go. Yeah, so that you will not interrupt the class. All right, so we have two operations. This is multiplication and addition. Multiplication and addition. I can do the distributivity of A over B and C. Okay? So that's equal to A multiplied by B plus A multiplied by C. Okay, that's what we call distributivity. So we have the distributivity of the multiplication over the addition, and then you have the distributivity of the addition over the multiplication. Okay? All right, and the same thing goes with the other, but we must be careful. We must be careful because there are some property that fail when it comes to subtraction and division. There are two properties that fail, especially the associativity, and we show that in some example. In associativity, we should please pass over there. That's a very simple thing, instance. You know that if you pass here, you interrupt the class. It's simple that you pass over there. Okay, it's very simple. All right. So for associativity, the associativity failed here. It failed for subtraction and then the division. We saw it. I'm just, giving an overview of what we did there. All right, and then last time also we start giving some property of real numbers. Okay, we start giving some property of real numbers, and okay, you can always check those property. What I just show with you now. So if we have if you take a number and then you add with the inverse, it will give you the neutral element. Okay, the neutral element. So we have what we call neutral element regarding to. If I say something that you don't understand, please stop me. Okay? Yeah. So if I say 2 plus minus 2, what will it give you? 0. Okay, so that simply means that 2 is the element, and I add 2 by the additive inverse. It inverse, the inverse. The inverse of 2 regarding to the operation plus is minus 2. But the inverse of 2 regarding to the operation multiplication is what? 1 over 2. Do you see the difference now? So if I say 1, if I say 2 multiplied by its inverse, the multiplicative inverse of 2 is 1 over 2. You see now? But the multiplicative inverse, the additive inverse of 2 is minus 2. Do you see now? So when I do the product, it will give you 1. So 0 and 1 are called neutral elements. Neutral elements. 0 are called neutral element regarding to the operation addition, and the 1 is the neutral element regarding to operation multiplication. Okay, so we have some few properties here. If you take an element and then you add the neutral element, the number doesn't change. So if I take A now and I multiply by the neutral element, it's still A, right? A, and then I add the neutral element, it's still A. Okay, so there are some few properties that you know because you will be needed in order to do some operation because you are dealing with for your business, you are in a business class. So you'll be always dealing with numbers. You should understand how numbers operate because you'll be having access to some data, numerical data. In order to understand the data, a data is full of numbers. It could be numerical data or numerical data. So you need to be able to understand numbers, real numbers, in order to maybe do a kind of work on the data that you are dealing with. Okay, so we also discussed about rational numbers. You know, you can do some operation of rational numbers. Okay, you can take two rational numbers. You know, every rational number can be written of the form A over B, right? Okay, and then if I ask you to do the summation of two rational numbers or do the product of two rational numbers, you need to be able to do that. Eh? Okay, so if I tell you 5 divided by 7 multiplied by 4 over 3, you need to do those operations. Okay, the operation of rational numbers. Addition, how you can add two rational numbers, how you can sum two rational numbers. Okay, we saw that. All right. So whenever you are doing summation, we call it, whenever you are adding two numbers, we call it summation, sum. And whenever you are subtracting two numbers, one with the other, we call it difference. Yeah, difference, okay? It's clear. But just know that we are our global set, because you know what is a set? Our global set is real numbers. Our global set is real numbers. Okay? And those real numbers, we all be dealing with real numbers. And if I say real numbers, the real numbers could be either rational numbers or irrational. Right? It could be either rational or irrational. Okay? Example of, who can give me an example of irrational numbers? An example of irrational numbers. Oh. Example of irrational numbers. Pi. Good, thank you. Pi. Very good. Yeah, pi is an irrational numbers. Okay? Yeah. Because you cannot write pi of the form A over B. You cannot write it. Mathematical is actually impossible to write pi in form of A over B. Any number that you are unable to transform it at the form A over B is irrational numbers. Example pi, another is exponential. Another is what? Is the square root of 2. Another example of irrational numbers. Square root of 7. Another example. Another example. Another example. Can you give me an example of irrational numbers? Okay, besides square root. Good, thank you. Another example. Yeah. Are you following? Are you following? Are you following the class? I hope that you're not sleeping here. Okay. Okay. You know exponential, eh? You know the number exponential? You know, you're familiar with that. Okay. Exponential is irrational numbers. So you'll be dealing with those numbers, eh? So you should be able to understand those are the value and so okay. Now let's continue. Then we saw we can actually discuss about even and odd numbers. What I mean by even and odd numbers. Remember that we started with rational. We said rational numbers is I can say the fathers of all numbers. It covers all numbers. Okay, let me maybe do the picture so that you see the picture. Okay, so we have n. N is natural numbers. Okay. We have the whole number. We have n0, which call we have natural numbers and the whole numbers, right? And the whole number is the natural numbers with 0. And we have what? The integers, right? And the integers cover negative, Okay, good. We have these decimal numbers, right? And we know that decimal number can be of the form terminal or repeating sequence, okay? So we have decimal number. I call it D. This is set, and then we have rational numbers, Q. And at the end here, we have real numbers, okay? So you see now, those are set of numbers, but one is included inside others. Okay, so if I do like this, you know what I mean, This is inclusion, a subset. Good, subset. It's inclusion. Okay? All right. Which one? A subset. Inclusion statement. Inclusion. That's mean that okay. So this class now, yeah. Let me take the set of females and the set of male. Set of female is one set, right? Set is a collection of elements. Set of male is another set, it's a collection of male. But all together, they are inside this group, BNS, BNS group 1, 2, 3. Okay? So I can say that the set of female is a subset of the whole group. You understand? Is a subset of the whole group, BNS 1, 2, 3. You understand? So when I say a subset, mean that this every element, let's say, you take two sets A and B, right? You say A is a subset of B if and only if you take any element that belong to A, that same element should also belong to B. That's a subset. Okay? And you understand the picture that I gave there. Clear? Okay, good. So now look at this this ordering. When you look at this ordering, you can see that this natural number is actually a subset of real numbers by transitivity. If I say you are less in age than her, and she's less in age than her, and she's less in age than her, that means that you are less in age than her, right? Transitivity. So if this is a subset of this is a subset of this, this is a subset of this. Okay? So whenever you are dealing with natural numbers, you are dealing with real numbers. Okay? Okay, so let's understand. In natural numbers, you have two types of natural numbers. They call it even numbers. An even number is every number that can be written of the form 2k. Yeah, 2k. Where k is I will show you now what I mean by 2k. 2 multiplied by something. So we are talking about even numbers. Okay? Those numbers can be written of the form 2k. Where k is a natural numbers. Do you see that? Any numbers, we call it even numbers. When this number can be decomposed of the form 2 multiplied by k, where k is a natural numbers. What do I mean? Let me give you an example. 4. 4 is equal to 2 times 2. Our k here is 2. Let's take 12. 12 is equal to 2 times 6. Our k here is 6. So 12 is an even numbers. Let's take 100. 100 is an even number. 100 is equal to 2 times 50. And 50 is our k. So any number that you could try to do the transformation, and then you will have a 2 that can multiply by another number is called even. 1,000 is 1,000 even numbers. Why? 500. Okay, good. That's even numbers. And then we have odd numbers. Odd numbers is every number that can be written of the form 2k plus 1. 2k plus 1, where k is natural numbers. Any numbers that you see that you can always written as 2k plus 1 is a natural numbers, is an odd numbers. An example, if I say 5 is equal to 2 times 2 plus 1, which is 4 plus 1. Yeah? So is odd numbers. If I say 11 is equal to 10 plus 1, and 10 is equal to yes. Okay, so 11 here is 2 times 5 plus 1. So you have the k, which is 5 here. So you see 2 multiplied by a number plus 1. Okay? You follow it, eh? All right. So that's what we call odd numbers. So if I take 57, is 57 a even or odd numbers? Okay, good. So we also know what's the composite numbers. A composite number is an integer that can be divided by at least one other than himself. Okay, a composite numbers. So let's take 12. 12, I can try to write 12 I can decompose my 12. Okay, yes, 12 is first of all different numbers, right? So I could try to do the composition in a form of prime numbers. So we learned last time what a prime number is, a factors. I can try to decompose this in the form of factors. I can factorize it. So 12 actually is equal to 4 times 3. So when you are doing the factorization, you should write the number in the form of the product of prime numbers. And you know what's the prime numbers? Huh? Right? The prime number is a number that have only two divisors. One and the number itself. Okay? If I say 15, 15 is not a prime numbers because it has 3 as a divisor. When I say divisor, if you divide that number by divisor, the remainder will give you 0. Will give you 0, okay? All right, so 12 is not a prime numbers. Right? Who can give me five immediate example of prime numbers? Yeah. Yeah. You. Looking at the back. You, yes. Can you give me 3 examples of prime numbers? 6. Oh, no. Me, sorry. 3, 5, 7, 11, 13, 17, 21. We have 21. 23. 29. You have 30. 31. 32. Okay, then you understand prime numbers. Okay, cool. So then, if you want to factorize the numbers, you have to write it as a product of prime numbers. Okay? So if I say 12 now is 2 square multiplied by 3. So our prime numbers are 2 and 3. So that's the decomposition. So 12 is called a composite numbers. It's called composite number because it can be written as a product of prime numbers. Okay? And the factors of 12 are what? What are the factors of 12? What are the factors? How many factors do you have? That's good, eh? All right. So that means that you're okay for now. You're okay for now, eh? Let's continue. continue. So we saw multiple. Which, a number is multiple. If it can be written as you take the numbers, you just write it as a product of two numbers. Any number that you can write it as a product of two numbers is called a multiple numbers. Okay? Example, 15 is a multiple number. Why? It can be written by 15 is what? How can we decompose 15? 3 times 5. Yeah, and the prime number is 3 and 5. Okay, good. And square root. A square root is a number where the value that can, if you multiply the number by itself, you get you take the square root such that when you multiply the number by itself, you get the number back. That's what you call square root. And how perfect square root then? And I say square root of 4 is what? 2. Square root of 9 is what? 3. Square root of 21 is what? It doesn't. Square root of 21 is not a perfect number. Okay, square root of 91 is what? Square root of 91. And also, so there will be some assessment where you do mental calculation. Yes, it's not all the quiz or assessment that you will be using calculator. You should be able to do mental calculation. Yeah. Okay. So just the basic operations, because if you take a number, then you want to do a calculation, and you take your calculator. The time that you go and take the calculator and start typing, if you use your brain, you can already solve it. Okay, so please also train your brain to do mental calculation and speed up your brain, because we do some quiz with mental directly. Okay, so perfect number, if I say square root of 121, what is the square root of 121? You should know to give me the answer. Yes. Square root of 144. Good. Square root of 150 is not a perfect number. Okay. Good. Okay. Now we want to study another section that's called place value. So, as we know that we are dealing with numbers, okay? Yeah. The basic part of this first chapter is that when you take a number, you should be able to get a better knowledge of that numbers. Okay? Classify it and be able to read the numbers. Write it. Be able to read the numbers. Okay? Yeah. So if I take a number now, then you start reading in your own way, that's not what we want. But you need to read it in a mathematical way, or maybe we have we adopt some certain convention that if taking a number, you should always read it like this. Okay, not your what you think. Okay, we adopt some rules that if I give you numbers, this is how you need to read it. And yes, as in the business, you maybe you'll be doing some presentation or maybe your thesis, and then you have some numbers, and then you have been presenting the things. You should be able to read the numbers correctly, and also be writing it correctly. Okay? So, in order to know how to write a number correctly, the efficient way, we need to understand what we call place value. Okay? So, we have value, we have a place, we have place value, we have, okay? So you need to be able to have a better understanding of what I just wrote now. Those are three things that are very different. Right? Okay? And prior to that, we have digits. Okay? Digits, value, place value. You need to get a better understanding of those terminology. Okay? So a digit, what's a digit? You know that we are working in the decimal numbers. Any number that you are writing will always be some kind of composition of with 0, 1, 2, 3 on 9. That's the basis where we are working. 0, 1, 2, 3, 4, 5, up to 9. That is called decimal basis. It's called decimal basis. So every number that you are dealing with, it could be decimal, it could be rational numbers, it could be real, and all. It will always be reading of those digits. It's called digits. 1 is a digit, 2 is a digit, 9 is a digit. Okay? And we agree that we are working under the standard basis. Our standard basis is decimal. Okay? You understand, eh? What you don't understand? Okay, I repeat again. Any numbers, we are dealing with numbers, any number, right, called real numbers, we will adopt a certain basis of digits, and those digits has to be from a set. It has to be from 0, 1, 2, 3, 4, 5, up to 9. If I say 12, 12 already is a combination of digits, which is 1 and 2, right? It's also a combination of digits because if you say 159, 159 is not a digit, but it's a combination of digits. It's composed by 1, 5, and 9. You understand now? It's composed by 1, 5, and 9. So any numbers, let's say 2 dot, this is what? Is it decimal numbers? Yeah. And those digits are what? 2, 5, and 7. What are the digits of this number? 2, 5, and 7. Yes or no? Okay. So now we agree ourselves that we'll be using decimal. We call it decimal as our digits. And the decimal numbers, okay, well, if I say decimal now, decimal basis, maybe it might be confusing. If I say decimal digit, because that standard basis we call the decimal, but it's not the decimal that you are thinking. Okay? All right. Okay, so that's our set of numbers. Okay? But also we have another set of basis, and we call it hexadecimal. But we will not deal with this now. Okay? Because hexadecimal, after 9 you get 10, and then 10 is representative of 10. In hexadecimal we call it A. Let's focus here, right? Okay. So, but all the number that you will be dealing with, the digit will always be of this form: 1, 2, 3, 4, 5, to 10. Okay, up to 9. Okay. Now, so you know what is the digit? The value. If I say 25, 25 is our value. Okay. But when you look 25 carefully, actually 25 has it can be decomposed. We can decompose it in a nice way. Actually, it has some one and some tens. It has some ones and some tens. It has some groups. Okay, that means when we are in high school, they teach us how to do some counting. Okay, so I take a group of. This is group of. Let's do like this: group of 1, and then I take another group: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a group of 10. This is a group of 1. Okay? So this 25 now, I can do it as a collection of 2 times this group of 10 plus 5 times this group of 1. Yes or no? That's the meaning, right? Because 25 can be written as 20 plus 5. Yes, 20 plus 5. And 20 is written as 2 times 10. So our will be function in a certain way, package. Ones, tens, hundreds, thousands. You see? So those will be our grouping of counting. If you want to count ones, tens, what is it? Okay, I said one. Yes, unit. Yeah, unit. Units ones. Okay, and then 10. 10 is a group of 10 units. Thousands, hundreds, and so on. Billions. Okay. So now, this one I can actually say that it is 2 tens and 5 ones. I can call it like that. 2 tens and 5 ones. I can read it like this, right? So that's my value. Okay. Now, what's the place? Any question? Any question? Okay, no question. Okay, so the place here now is the position. Is the position of any digits from these numbers. The position. So if I tell you what's the position of 2, 2 is at the position tens. Alright? So that means what? Our place, the place of 2 is what? Tens. 5 is at the position ones. The place of 5 is what? Ones. Let me give another example. Complicated. Maybe not complicated, just simple. These are simple numbers. Okay? So what are the digits of these numbers? 5, 4, 7, 8. Okay? Okay? Those are the digits. So if I want to write those digits, those are the digits. And what's my value? This is my value. Okay? And if I want to read it in the form of what we are discussing now, we can actually start doing the units. We have actually 1 unit, 10 units, 100 units, 1,000 units, right? So this now I can do reading as follows: 5 hundreds. Okay? Okay, thousands. Yeah. 5 thousands. 4 hundreds. 7 tens and 8 ones. Okay, good. Perfect. All right. So then I can now be looking. What is the place of 5? What's the place of 8? Huh? What's the place of 4? Good. Perfect. Okay. So the place now value. Okay, so the value. So we understand what's the place, and we understand what is now. What's the place value? Taking this example now, okay? What is the place value? You know that when we are here, if I tell you 5, the place is what? Thousands. That's the place. Okay, maybe let's do this example. If you take the example of 2, 5, 4, 7, 8, our digits are 5, 4, 7, 8. I mean, those are the digits. I write it like that. Okay? And 5, if I take place of 5 is what? 1,000. Okay? 4, what's the place of 4? Hundreds. What's the place of 7? tens. What's the place of 8? Okay, good. Now, for every place, I will get my place value. For each place, I will get my place value. Okay? So what is the place value of 5 now is what is actually the quantity of that number inside the number. The value. So it's what? 5,000. What's the place value of 400? Huh? What? Tens. 70, and this is 8, right? Yes or no? Yes. Okay. So when you are looking at the places, you should not say the place of 5 is thousands. It's not 5,000. You see the way that I'm writing this, you might think that the place is 5,000. It's not 5,000. I said the place of 5 is 1,000. You understand? Okay. Just the way that I read it. The place of 5 is what? 1,000. That's all. The place of 8 is what? That's all. Okay. Good. So, what's the time now? We're almost getting closer. So, did you have a better understanding of this basic? So, flow chart in the class. We're not charging it here. Okay? Yeah. You have a question? Okay. Any question? Okay, we can continue. So now we want to, I will show you because what's the idea why we are trying to show this step? Because we want to understand how to do mental calculation. Because if you want to do mental calculation, if I give you a number, you need to write it in your brain, the composition, and then start adding the thousand, start adding the hundred, start adding the ones, and then you do the summation. That's all, and then you give the answer. Yeah? You understand? Okay, guys. Did I raise it? Okay, so we are progressing. Okay, let me, for instance, that number, which number we are dealing with? I just write it there. Which number we are dealing with? 4 what? 7, 8. This now is equal to what? 5,000 plus 400 plus what? 70 plus 8. You see now the representation? Yeah. That is called expanded notation. I just expand it now. You see now? I expand it now. So, I give an example. Suppose that I want to do plus 257. Can you give me the answers? What's the answers? In 10 seconds. Don't use the calculator. There's no comma there. Where is the comma there? You see a comma. You see a comma. 488 plus 257. All the answers. You sure? You use the calculator. I see you. There's no cheating there. Yeah. What's the answer? I will show you now how we can do it mentally. So what you need to do quickly, you need to write this one in its expansion form, the expanded form. So 400 is equal to 400 plus 80 plus what? 80. Yes? Plus now. Let me do this. Okay. Let me do like this. Okay? Yes. Okay? So if this is the first one. Okay? Now this is 200 plus 10 plus 2. Yes or no? Okay? So if you want to do mental calculation, you need to first write the expanded standard representation first. Now you start adding the hundreds, the thousands, the ones, the billions, and then you do the summation. So now you need to group 400 with 200, which is what?